So today we're talking about analyzing graphs of functions and relations, and hopefully by the end of the lesson you'll be able to find information about different graphs, explore symmetries, and identify even and odd functions. So you can use graphs to estimate different types of things about a particular function. Let's just jump right on into it with an example. Here we have the approximate numbers of annual visitors to a park from 2000 through 2008 can be modeled by this v of x function, where x represents the number of years since 2000. Look at your graph. 2, 4, 6. Those represent the years after 2000. So the 4 will correspond to what? 2004. And if you look at your y-axis, the number of visitors is in thousands. So 17 is not 17 people. It's really
17,000.
Wonderful. So here we go. Use the graph to estimate the number of visitors to the park in 2006. Well, 2006 corresponds to what on the x-axis?
Year.
Oh, wait. 6. So we see where 6 touches the curve. So if we kind of draw a little horizontal line over, we see that it is right under 17. A little bit more than half, right under 17. So what's a good number? Like 800. It's an estimate, so it's all good. But we can figure this out algebraically. Like in part B, find the estimated number of visitors in 2006. What do you think we're going to do here, Alexis?
Plug in 6
4.
for x.
Very good. So we're going to evaluate v of 6, which means that we're going to plug in 6 everywhere we see an x. And when we type that in, but it's not 16.65 people. That's not even possible. Remember, the y is in thousands, so the answer is
16,650.
wonderful, yes. In what year did the number of visitors first exceed 2,000? Well, 2,000 corresponds to what on your y-axis? The 20. So you see where it hits the curve. Drop down the perpendicular, and what year is that?
2007.
Wonderful. You can also figure this out using your calculator. Everybody go to your calculator. Wonderful. Hit y equals. Clear out whatever functions are in there and type it in. Are you guys typing it in?
Yes.
Wonderful. Okay, let's see if I can remember what the function is. It was not a, what was it, a minus?
Minus 0.51 x squared plus 1.81.
Does everybody have this in there? Does everybody have all the x's in?
Yes.
Wonderful. So before, please tell me no one press graph. Okay, we are going to have to fix our window a little bit. Our window is basically what we're actually going to see on this graph, okay? So everybody click the window button. It's located right beside the y equals. And look at the graph that's on your paper. X-min represents the smallest x value. What's the smallest x value on this graph? 0. So our y-min is going to be 0. If it's already 0, that's cool, but if it's not, change it. The x-max, look at your graph. What's the largest x value that your graph shows you? 8, 9, 10. Put one of those in there for x-max. Make sure your scale is 1, because we want the units on the x-axis to go by ones. Okay? Y-min, what's the smallest y value on that graph? 0. And the largest? 23. Now, yes, it's technically 23,000, but we're just going to use 23 so we don't have a super big graph. Okay? And now, we can graph it. And you should get a curve. Yes, it's not going to look like the one on your paper, just because, you know, the scale looks different. And press graph, yes. Raise your hand if you did not get this. All right, so we're going to fix a couple things. Go back to your y equals. We're going to try to find the specific year that we did exceed 20,000 people, okay? Now 20,000 corresponding to what on our y-axis? 20. So we're going to type in 20 into y2. And now graph. What you'll have is two lines now, or two curves. your curve that represents your function, and then the straight line that represents 20. We're trying to figure out what is that point right there where the two lines intersect. Are you ready? Press the second button. Press the trace button. Trace is located right beside the graph button. Anyone following along? Go down to intersect. So we're going to basically try to figure out where those 2 points intersect. Click enter. You should have first curve. Don't move the cursor, just click enter. Second curve. Don't move nothing, just click enter. Yes? Don't move anything, click enter again. And the calculator does all the work for you and tells you that the x value that year is 7.74. So we were right, 2007. There you go. A little bit of calculator, you know, 101. Let's keep it going. Okay. So, here we go. Find the domain and range of each function. We talked about domain the other day. Algebraically. This time we're looking at pictures to try to figure this out. Domain relates to what variable, x or y? X. If you didn't know that, you might want to write that down. Domain relates to x, and range will relate to what? Your y's. So when you're trying to figure out your domain, when you're given a graph, when you're given a picture, you want to find out where that graph starts and where that graph ends. Okay? And since we're talking about domain first, where on our x-axis does this graph start? Well, this graph starts right about here. What x value is that? -4. Because the scale goes by 2's, and this point is at -4, -6. And remember, domain relates to your x values. So I start at -4. And I go up, I go down, go back up, and I stop right here. Where's this point located? 3, 5. So my domain, it stops at 3. Are these points included? Yes, they are, because they're closed circles, aren't they? So I'm going to use the brackets. And there's my domain in interval notation. So where I start, where I end in relationship to your x's. Yes? And that's what you want to do. You want to look at your endpoints, because that's where you start and where you finish, and you look at the x values.
Why did you use that?
Because since the points were closed, that means that it was defined at -4 and at +3.
Oh,
We do the same thing with our range. But this time we're looking at the y's. So I start where? -6. Is that point included? Sure is. And we go all the way up to what number? 5. Is that point included? And there's our range. Okay? Where we start to where we finish, domain is x, range is y. Questions? Let's practice set. We're going to do set for the second one. One person raise their hand, tell me what they think this arrow means. Raise hand, Shay. It's not Shay? So Shannon, what does that mean?
that it doesn't stop
It doesn't stop there. It keeps going. To where? What'd you think?
down, back,
Yep. What number?
infinity,
Infinity. Positive or negative?
negative.
Negative. So when we think about our domain, it's from negative infinity all the way to 4. How do I represent that to put into my set notation? I'll take a raised hand volunteer on this one. Stephen. That would be in my interval notation. That's cool though. But let's practice the set. Think about it. Set. That's with the curly brackets, with the bar. There's something that goes right here. Alexis?
X is less than 4.
Very good. X is less than or equal to 4. It's all of my values that are less than 4. And since it's a bracket, it's equal to. What goes in front of the such that? And X is an element of what numbers? Real. There's my domain. Now my range, those are my y's. I go all the way from negative infinity to, careful with the scale, to 3, because it's defined all the way up to 3. So how would I represent that in set notation? There's interval, but how would I represent it in set? Think about it, I'm trying to represent all the values between negative infinity. It's y, but y is less than or equal to what number? 3. So I need a y at the front. It's the set of y values such that y is less than or equal to 3. And then y is the element of what set of numbers? All real. And there you go.
So you use y because of range and x because of domain.
Exactly. Use y because of range, x because of domain. Yes? Why wouldn't be -1 is, even though yes the graph stops there, it does not go as high as -1, it goes higher. So think about it, if I'm tracing along this, the highest y value I go is right up here to the top. And then I go back down. So I'm still including any values that are greater than -1. 0, 1, 2, 3. I don't go any higher than a +3 though on my y-axis.
So your y-axis is always the highest.
Highest to lowest, yep. Or lowest to highest. And x, where you start to where you finish. This next one. Loose on my other periods minds. I'm gonna do my best to try to explain this. Okay? No, you don't connect the dots. What do you guys think? What type of function is the last one? It's a piecewise. Okay? Piecewise domains and ranges. In this particular case, it's just a tad bit different. Alright? Does everybody have to write down? Everybody have the space. Okay, here we go. Now, just out of curiosity, when you think of domain, are you thinking, hey, from here to here, from here to here, from here to here? Are you thinking that? You do move from left to right. Where do I start?
At the open, right there.
Right here. What x value is that? -5. We're going to write both of these in interval notation. So we're going to start at -5. Is that included?
No.
No. So we got a parenthesis. So I'm going along. I reach -1. It's an open circle. It's not defined on this piece of the function, but it is defined on the other piece of the function. So I don't stop at -1 because it's still defined at -1. I keep on going until a point where it's not defined. It's not defined at 2 on either piece, is it?
No.
So I end at 2. Is 2 included? Because right here, on both parts of this piecewise function, 2 is not defined. Okay, so it's never equal to 2 at any point. Like if I gave you the piecewise function and asked you to evaluate it at 2, you wouldn't be able to give me an answer because it's not defined anywhere.
I thought it was
We're in the oh. Now we gotta represent the rest of this. It goes from 2 to what number? Infinity. And how do I connect those? With the u. And there's my domain.
that was
Pretty sure people still walk out of the first and third period like, what? The range. Where is it defined? From lowest to highest. Well, the highest that I can go is what? Infinity. The lowest is where? -4. It's defined at -4. However, between -4 and -2, it's not defined, is it? then from -2 to infinity is defined, correct? Okay, so we can do that part, right? It's defined from 2 to positive infinity. That represents from here all the way up. And that 2 to infinity also includes this part right here. Just think about it, this is at 3. 3 falls in between here. Oh, -2, I apologize. You got this 4. In these cases, 4 is by itself. It's not arranged, it is just 4. So when it's just one number as a part of your range, you literally write that one number. And then of course you put the U to connect the other part of the range. -4. I do apologize. It is negative. Say again? Well, order. Negative, positive. So that's why I put the -4 in the front, because it's order from negative to positive.
So you don't have to worry about like parentheses or
Because it's only defined at -4. Not -4.2, not -3.9, just a -4. Yes, ma'am.
So you just write the number when it's a closed circle?
When it's just a line and nothing else connects it along your range.
Is
So-
that the one where it was just like 3?
Yeah. Yep.
Why is the 2 negative?
Why is the 2 negative? Because right here, this point starts at -2. I'll get questions. Anyone? Turning along. So find the y and x intercepts. You guys have done this before. The y-intercept is where the graph crosses the y-axis. To find that, you evaluate f of 0. That means you plug 0 in for x. And it's all. To find the x-intercepts, also known as your roots or your zeros. More than likely, that's how they'll be referred to, roots and zeros. You set f equal to 0 and solve for the independent variable. Most of the time, that's x. You have an x and y. So for y-intercept, you plug in 0 for x. When it's an x-intercept, you set it equal to 0. Okay? Now, we're a little short of time, so I'm only going to do one example, so at least I can get to even and odd functions. Yes, I can look at the graph. I can see where the x-intercepts are. Where are they? Careful. -2 and? Try again. 6. The scale, I know. They're my x-intercepts. My y-intercepts are what? Is what? Is that -12? Yes, I can look at the graph and I can see that. However, you won't always be given the graph. So to find your y-intercept, you actually plug in 0 into your function for x. So that's 0 squared minus 4 times 0 minus 12. Well, 0 squared is 0. -4 times 0 is 0. So it's just -12, and that's what we saw on our graph, correct? Y-intercepts are written as a point. 0, -12. That's how you do it algebraically. Questions? That's pretty straightforward. Your x-intercept, you have to set your function equal to 0. To do that, 1. Now this is a quadratic. You got to factor. 2 numbers that multiply. That's how that one factors. You apply your properties. 0 product. X minus 6 equals 0. X plus 2 equals 0. So x is what number? And x is what number? And isn't that what we saw on our graph? And its intercepts are written as points as well. So that's 6, 0, and negative 2, 0. So you can do them algebraically, or you can look at the graph and find them out. It's good to know both ways. Especially if one doesn't fall exactly on the line, you can get the exact answer. Questions? So we got domain and range, we got x-intercepts, we got y-intercepts. Last thing, symmetry. A graph has line symmetry if it is symmetric to the x or y axis. Why? Because those are lines. And you have point symmetry if it's symmetric to the origin. Basically, you're going from the first quadrant to the third, or the second to the fourth. Symmetric. Functions that are symmetric to the y-axis are known as even functions. Functions symmetric to the origin are known as odd functions. So you could look at a graph. If I fold right at the y-axis, then that means it has symmetry with respect to the y-axis, but it's also even. Odd, it has origin symmetry. But to figure it out algebraically are these two things here. What this means, you plug in negative x into every single x and simplify. If you get the original function, it's even. You get the same thing after you simplify. But if you get the exact opposite, meaning that every single sign changed from positive to negative or negative to positive, it's odd. If it's not the same, and if it's not the exact opposite, it's neither even nor odd.
The one with the exponent, right?
What?
Okay. I'll walk that down in a second.
Exactly. Let's look at an example. Really quick, you probably only get through one. That's okay. Alright? Let's figure this out algebraically. I plug in a negative x into every x that I see. You gotta be careful. Negative x cubed. What is that? Negative x cubed. It is negative x cubed. Think about it. Negative x times negative x is an x squared. Times another negative x is a negative x cubed. If I multiply 4 and a negative x cubed, that gives me a negative 4x cubed plus 1. That is my function simplified after I plug in a negative x. Is it the exact same thing as my original? No. Is it the exact opposite? Careful. Is it everything the exact opposite? No. Because there was a plus here and still a plus there, it wasn't the exact opposite. Everything needs to change. Every single sign of every single term needs to be the exact opposite. So since it's not the exact opposite and it's not the exact same, it is neither. Okay? Let me show you on the graph real quick. If I type that in, that's 4x cubed plus 1. Here's the function. It's not symmetric about the y-axis, so it's not even. Because if I fold it right at the y-axis, it would be the same thing on the other side, which is not. And it looks like it's almost the origin, but the thing is, this little hump right here, it would have had to gone through the origin in order for it to be origin symmetry, or odd. So this is what a neither, even nor odd function look like. Does everybody understand that? Okay, cool.